2026 has so far proven to be a pretty busy year for new climate publications. There have been several major bits of research and data released in recent months, all pointing in a similar, slightly disturbing direction. Faster warming, growing instability in major Earth systems, and potentially larger impacts than previously estimated. All of which could be, and in some sections of the media is being, rolled into a single dramatic apocalyptic narrative. Now, I like a nice dramatic apocalyptic narrative as much as the next person, especially if it's in a good movie. But in the real world, I prefer to apply a bit of careful thought to all the analysis. So what are all these studies actually saying? Are they all in agreement? And what can we reasonably conclude from the evidence as it stands today? Hello, and welcome to Just Have a Think. Let's start with the most fundamental of all the questions raised in recent papers. Is the Earth warming faster than we expected? Well, according to this analysis, published in March by Grant Foster and Stefan Rahmstorf in the online journal Geophysical Research Letters, the answer is yes. Before we get stuck into the data though, I wonder if you might just take a couple of seconds to click the like and subscribe buttons just down here. Those clicks are completely free, but they really are the lifeblood of any YouTube channel. So if you like these types of videos and you want to keep up to date with the latest publications, then subscribing is the easiest way to do that. And of course you would have my eternal gratitude if you did. So what does the observed data tell us then? Well, it suggests that the rate of global warming over the past 10 to 15 years appears to be higher than in earlier decades. According to Foster and Rahmstorf, between 1970 and about 2015, the rate of change was 0.2 degrees Celsius per decade. But since then it's been closer to 0.35 degrees Celsius per decade. Now that might sound like dancing on the head of a pin, but as a plot on a graph it represents quite a step change in the trend line, and that's got scientists scrambling to work out exactly what's caused it. Some, like James Hansen and others, point to a significant reduction in aerosol pollution, especially from sea freight. Those aerosol particulates tend to reflect incoming sunlight back away from the Earth's surface. So ironically, while they were caused by the combustion of fossil fuels, which are incontrovertibly the main driver of additional warming, their presence in the atmosphere actually had a cooling effect. Now that they've been largely regulated out of shipping exhaust emissions and also reduced in many urban conurbations across the globe, the so-called aerosol dimming effect is diminishing, revealing the true extent of human-caused warming. Others, like Professor Michael Mann, Professor of Earth and Environmental Science at the University of Pennsylvania, point to natural variability, particularly in ocean cycles like the ENSO system that we looked at in our previous video. He and his colleagues highlight the fact that there have been 2 strong El Niño events since 2015 and argue that these events have caused a bit of a blip in the data. The long-term trend since 1970 has basically not changed, argues Mann. The planet is warming at a roughly constant rate, and that's bad enough, he said recently. It will continue to do so until carbon emissions reach zero. But then there's research suggesting that overall climate sensitivity may have been slightly underestimated and that actually our Earth systems are responding more acutely to human-induced climate forcing. It's enough to keep the average person's head spinning, and of course it's manna from heaven for the climate denial brigade because it enables them to completely mischaracterize normal scientific divergence and uncertainty as signs of incompetence or even deception, which of course is a proven and very effective way to sow just about enough doubt in people's minds for them to justify sticking with the status quo. But it's important to be clear here, even though we don't have unanimous, unambiguous, settled conclusions and certainty on the rate of change in these Earth systems, what the climate scientists can say with confidence is that observational datasets continue to show a persistent pattern of record or near record temperatures in recent years. So whether or not the rate itself has increased, the direction of travel is not in question. The system is warming, and it's doing so in line with, or in some cases toward the upper end of, previous projections. And then there's the recent coverage of the Atlantic Meridional Overturning Circulation, or AMOC, something we've looked at several times over the years, the vast system of ocean currents that transports warm water northwards and cold water southwards, playing a key role in regulating climate, particularly in Europe. According to a major new paper published in Science Advances, the AMOC may be weakening more quickly than previously thought. The study, led by Valentin Portman and colleagues, combines real-world ocean observations with climate models and concludes that the circulation could weaken by around 50% by the end of this century, which is significantly worse than earlier model averages. The authors aren't saying collapse is imminent, but they are suggesting that the system may be closer to a critical threshold or tipping point than previously believed. And that conclusion does seem to align with other recent findings. There is still some disagreement in the literature on the specifics of timings and rate of change, so again, just like with all future predictions, it's not possible to offer absolute certainty, but again, the science is showing increasing evidence of vulnerability in the AMOC system, so there is important value in continuing to monitor and observe the changes as closely as possible, even if we occasionally get contrasting or conflicting results, because the consequences of major weakening or even a collapse of the AMOC will be pretty brutal. It means significantly less rainfall over West Africa, which is already highly drought prone, and also less rainfall over the Amazon, which I think we can all agree is a fairly important region for the entire planet's climate. Conversely, there would be increased rainfall in parts of the southern hemisphere tropics, which already experience extreme flooding and could do without any additional stress. Those changes will in turn influence agricultural productivity, particularly in those regions already vulnerable to drought. A collapsed AMOC would also bring far colder conditions to northern and western Europe and cause significant sea level rises along the eastern seaboard of the USA, potentially impacting major coastal cities, societies, and economies. Which brings us to a further set of discussions in recent publications talking about how individual tipping points are not moving in isolation but are all interconnected with each other. This paper, published in February 2026 on the One Earth website by climate experts including Johan Rockström, highlights the risk of tipping cascades rather than individual tipping points. Essentially, the Earth systems are a network, the authors explain. Changes in one part of the network can increase the likelihood of changes in another. So, for example, ice sheet melt adds fresh water to the ocean. That fresh water can weaken circulation systems like the AMOC, which in turn can affect global heat distribution, which then feeds back into further warming. We're already heading for increases of 2.7 degrees Celsius by the end of the century with current policies, and literally as I was about to start editing this video, an early draft report was published revealing the newly calculated and calibrated climate warming scenarios that will be included in the next eagerly awaited assessment report from the IPCC, known as AR7. Despite the fact that the IPCC has now done away with their pretty implausible so-called RCP 8.5 scenario, which assumed the world would increase coal use sevenfold from 2010 onwards, something that patently hasn't happened, and even if we shield our eyes and choose to ignore the recalibrated high scenario in this new chart, the so-called medium scenario still looks alarming enough. It tallies pretty well with what Johan Rockström and his colleagues are warning, namely that if we don't decelerate our emissions and decarbonise extremely rapidly, then there's a very real risk we could stray into the region of 4 degrees Celsius or more of warming, at which point, the authors warn, the economy and society will cease to function as we know it. Now, Rockström and his colleagues are not saying that a hothouse Earth scenario is inevitable, but they do seem to be strongly warning that the risk of crossing multiple interacting thresholds increases as warming progresses, and crucially, those risks are not always well captured in standard climate or economic models, which means our organisations, institutions and policymakers may not be responding as urgently as they should be. According to this recent analysis, there's growing concern that the widely used economic models may be underestimating the true cost of climate change. Many models assume gradual, linear changes, smooth, seamless adaptation by governments and societies around the world, and relatively limited disruption. But of course, that's not how the real world works, is it? Extreme weather events like floods, droughts, and heat waves push us towards potential tipping points that introduce the possibility of non-linear shocks. In other words, impacts that are larger, faster, and more disruptive than expected. Again, this isn't presented as a certainty, but it is a growing area of concern within the research community. For many people, the most immediate expression of climate change isn't ocean circulation or economic modelling though, it's heat. And here, the evidence is perhaps the most direct. Heat waves are becoming more frequent, more intense, and in some cases, pushing into ranges that pose serious risks to human health. The very latest European State of Climate report tells us that at least 95% of Europe experienced above average annual temperatures in 2025. The annual sea surface temperature for the European region was the highest on record, and 86% of the region experienced at least strong marine heat waves. And European wildfires burnt well over 1 million hectares, the largest area on record. A record 3-week heatwave affected Scandinavian and Nordic regions, with temperatures near to and within the Arctic Circle exceeding 30 degrees Celsius. Glaciers in all European regions saw a net mass loss, with Iceland recording its second largest glacier loss on record. Snow cover was 31% below average, and the Greenland ice sheet lost 139 billion tonnes of ice. None of the analysis we've looked at so far amounts to a single inevitable outcome, but taken together, they all point to increasing systemic risk. The question I get asked most often in the comment section of videos like this is, what can any of us actually do about it? I mean, it's all very well for someone like me to be blathering on about risks in global climate systems, but most of us are just trying to navigate our daily lives and don't feel like our individual efforts amount to a hill of beans in the face of such enormous global forces. Right now, though, the answer is arguably not just about climate, it's about resilience. For example, at the time of making this video, tensions in the Middle East and disruption around the Strait of Hormuz are pushing up global oil prices. And that's a reminder that fossil fuel dependence isn't just an environmental issue, it's also an issue of economic and geopolitical vulnerability. So maybe the most relevant conversation isn't just about reducing emissions, it's about reducing exposure to an ever more erratic and unreliable source of energy. As individuals, we can switch to an electric vehicle wherever and whenever it's practical and affordable to do so. We can take steps to insulate our homes and, if possible, electrify our home heating and cooling, most likely with heat pumps. And we can start to generate our own electricity locally with solar panels and battery energy storage, the cost of which has been plummeting in recent years while efficiency has continued to improve dramatically. It won't solve the entire climate emergency in one fell swoop, but it will reduce your reliance on fossil fuels, which means lower exposure to price shocks, greater energy independence, and a lower overall demand for oil and gas. And as the recent election results in Hungary demonstrate, those of us fortunate enough to still be living in ostensibly democratic societies can and absolutely must vote for the changes we want to see. Individually, each of our actions is small, but collectively, they shift the system. So yes, there's a lot of new research, and yes, most of it's pretty concerning, but none of it is pointing to a single guaranteed point of inevitable catastrophe. It's pointing to a set of planetary systems under increasing stress, with rising risks that are becoming harder to ignore. The trajectories of those systems are not fixed, though. They're all still highly responsive to human decisions. And the same actions that reduce the risk of those systems breaking down also just happen to make our energy systems more secure, more stable, and ultimately more resilient. Now, I'm sure many of you have got your own strong views on this one, so as always, the place to leave your thoughts is in the comment section below. That's it for this week, though. A huge thank you, as always, to the absolute legends who support the channel via Patreon and help me keep ads and sponsorship messages out of all my videos. And I must just give a quick shout out to some folks who've joined since last time with pledges of $10 or more a month. They are Fred S. Aaron, Lorenzo Labrador, Patrick Burns, Thomas Tilker, Phil Rundle, and Anders Kirschenbauer. And of course, a huge thank you to everyone else who joined recently too. You can join them and get the chance to leave feedback on preview versions of each video and take part in monthly content polls and chat directly with me by visiting patreon.com/justhavathink. Don't forget to like and subscribe if you found this video useful. And most importantly of all, thanks very much for watching. Have a great week and remember to just have a think. See you next week.